Hi guys, and welcome to video number 3. If you do not have your Unit 8, Chapter 10 notes out, please go get them out now so that you can follow along with this video. Okay, so what we're doing here today is we are looking for solutions to the parabola. And so right here it says a solution is where the parabola crosses the x-axis. These are called the roots. And remember, when you did linear equations or equations of lines, you looked for where the solution was, which was called the x-intercept. And so these equations right here, these parabolas, they're set equal to 0 because the value of y when you're finding the x-intercept is 0. So we're setting y equal to 0 so that we could find where this parabola is going to cross the x-axis. All right, so we already know that this parabola here, if you were to find the vertex, it would be at 0, -9. So if you did your equation, you found the vertex. So I'm going to put a little point here at 0, -9. So it means down here would be my vertex, okay? So now let's find the x-intercepts. And again, we have it set equal to 0, so we can go ahead and factor this. This is factorable into x plus 3, x minus 3 equals 0. Because remember, this is what we call a difference of squares. There's no middle term, so x times x is x squared, a positive 3x and a negative 3x. If you add them together, they'd cancel out, they'd go to 0. And positive 3 times negative 3 is going to give us -9. Now remember, both of these are set equal to 0. So if you say x plus 3 equals 0, you would subtract 3 from both sides, and you would get x equals -3. Here, if you set x minus 3 equal to 0, you would add 3 to both sides, and you get x equals 3, which means this parabola is going to cross here at -3, and it's going to also cross here at +3. So if I go ahead and I connect these dots here like this, here's my parabola, which means this has 2 solutions. And those solutions are, again, where your parabola crossed the x-axis or the x-intercepts. So our solutions were -3, 0, and 3, 0. All right, let's take a look at this one. Now this one, x squared equals y, means it's the parent graph, or it starts at 0, 0. If you went ahead and solved for the vertex of this equation, you would get right here. So if you did, you get 0, 0. And if you notice this one here, starting at 0, 0, it's already crossing the x-axis. So I know this is a positive parabola. I know it's going to go up something like this. So I know this one right here would cross on the axis. So this would have 1 solution. And in this case, since it was on the origin, it's 0, 0. All right, so let's take a look at the next one. So this equation here, if you were to go ahead and set it up so you found the equation of the vertex, you would get 0, 4 as the vertex. So if we go ahead and plot that vertex, we're already at 0, 4 right here. And we can also tell that this is a positive parabola, so it's opening upwards. So just by looking at it, I already know it's going to go up something like this. So therefore, if a solution is where the parabola crosses the x-axis, just by looking at it, is this going to cross the x-axis? No, it's not. So since it's not, this would be an example of no real solution. All right, so that is how we solve them by graphing. So wherever it crosses the x-axis, those are the solutions. Now you could also solve it algebraically. So what we're going to do here first is we're going to try to get x squared by itself. So to do that, this is saying 2 times x squared. I'm going to divide each side by 2. I'm going to get x squared equals 0 over 2, which is going to simplify to 0. So when I take the square root, I get x equals 0. So that means there's 1 solution at 0, 0. Okay, so because if you plugged it back into the equation, you'd get out 0. Let's go ahead and try this one. I'm going to subtract 2 from both sides. So I get 2x squared is equal to -2. I'm going to divide each side by 2. So I'm going to get x squared equals -1. And if I take the square root, I can't take the square root of -1. It's an imaginary number, which means this would be no real solution. Because you can't take the square root of -1. You would get an imaginary number, not a real number. All right, for number 6, I'm going to start by adding 2 to both sides. So I get 2x squared equals 2. I'm going to divide each side by 2. And I'm going to get x squared equals 1. So now in this case, I can take the square root. And when I take the square root, remember you're getting a positive and a negative answer. So you get plus or minus 1, which means this x-intercept would be at -1, 0 and 1, 0. So this would have 2 solutions. And remember, when you take the square root, you get a positive answer and a negative answer. The other way you could have done this one here is if you could have said x squared equals x squared equals 1. And you could have subtracted 1 from both sides, and you get x squared minus 1 equals 0. And then you could factor that into x minus 1, x plus 1 equals 0. And then remember, since you have your 2 solutions here, you can get x equals 1 and x equals -1, which is going to give us these same answers. But do it whichever way you prefer. It's probably easier to do it with the square root method. Just be careful. Remember that taking the square root gives you a positive and a negative. Okay, so right now pause the video and try to do 7 and 8 and then check your answers. Okay, so let's see how you did. So on number 7, so when we took the square root, we got x equals plus or minus 5. So then our solutions were -5, 0 and 5, 0. Because remember, a solution is the x-intercept, and the value of y at the x-intercept is 0. That's why y is 0, because you set y equal to 0 here. So for number 8, when you simplified it, it did not simplify into a whole number. When you took the square root, you got the square root of 13. We don't want to use a decimal at this point. You want to leave it as a radical, which is considered an exact answer. So we're going to say the negative square root of 13, 0 and the square root of 13, 0. If we were to graph these, you could turn them into decimals and then graph them on the x-axis. But for right now, since we're solving algebraically, leave it as an exact answer. Okay, thank you for watching the video.